In this video, you will learn what an interval is and how to measure it. An interval is the distance between two notes. Each interval has its own sound and name. In this chart, I have written all intervals in an octave, so there are 12 half steps in an octave. An interval name consists of two components, a number and a description. So far, we have encountered the half step and whole step intervals. Each interval has a particular number of half steps. To recap, a half step is the distance between a key and its nearest key to the left or right. On the piano, it's possible to measure an interval by counting the number of half steps between the two notes. For example, let's find a perfect fifth interval above middle C. The interval chart shows that a perfect fifth interval equals 7 half steps, so let's count 7 half steps up from middle C. We land on the note G. Obviously, we can use any note on the piano as the bottom note and count 7 half steps up or down to get a perfect fifth interval, and the interval will sound alike. So let's count 7 half steps up from E. We land on the note B. Notice the similar sounding interval when alternating between the two perfect fifth intervals starting from C and E, respectively. To hear the distinct sound of the intervals, let's play all intervals using middle C as the bottom note. When dealing with large intervals, measuring intervals by counting the number of half steps is cumbersome. So I will present another interval measurement method. It's a scale-oriented method of measuring intervals that might be more useful on the staff. To get the interval number, we count up from the bottom note and include all the successive line and space notes until we get to the top note. It's important to count the bottom note as number 1. In this way, we get the correct fifth interval from C to G. We can also count the number of note letter names, as this will also result in the correct fifth interval. For this, we can use both the staff, piano, and our memory of the music alphabet. So, C is 1, D is 2, E is 3, F is 4, and G is 5. Now, we know the interval number, but we still don't know what type of fifth interval it is. We need the interval description. To get the interval description, we need to understand the concept of diatonic and chromatic intervals. A diatonic interval is created when the upper note of an interval is contained within the major scale built from the lower note. On the contrary, a chromatic interval is created when the upper note of an interval is not contained within the major scale built from the lower note. Let's see which internal intervals are present in the C major scale. There are only two types of intervals in major scales, major and perfect. Therefore, major and perfect intervals are classified as diatonic intervals. As all major scales are constructed similarly, the internal intervals are the same. So no matter which major scale is used, the perfect and major intervals will be present on the same scale degrees. The fourth scale degree of any major scale will always be a perfect fourth interval above the first degree, or tonic of the scale. Similarly, the fifth scale degree of any major scale will always be a perfect fifth interval above the tonic. And the second, third, sixth, and seventh degrees will always be a major second, third, sixth, or seventh interval above the tonic of any major scale. The octave is considered a perfect type interval. Let's create some different major scales to see that the diatonic intervals remain the same. Looking at the interval chart, we see that there are 5 types of intervals: major, minor, perfect, augmented, and diminished. The minor, augmented, and diminished intervals were not present in the major scale. Therefore, they are chromatic intervals. To derive a chromatic interval that's not part of the major scale built from the bottom note, we need to learn the following chromatic interval description rules. 1. A major interval reduced by a half step becomes a minor interval. 2. A minor interval reduced by a further half step becomes a diminished interval. 3. A major interval increased by a half step becomes an augmented interval. 4. A perfect interval reduced by a half step becomes a diminished interval. 5. A perfect interval increased by a half step becomes an augmented interval. Let's go through some examples of diatonic and chromatic intervals. To the left of each interval, I have included the major scale built from the lowest note. This is for reference. Example 1. In the first example, we have an interval from E flat to B. Starting at 1 and counting all line and space notes between the two notes on the staff, we get an interval number of 5. In the E flat scale, the fifth scale degree is B flat, so the perfect fifth interval above E flat is B flat. However, the upper note in our interval is B, which is a half step higher. Therefore, this is a chromatic interval. So we need to reference the chromatic interval description rules to know the resulting interval description. Rule number 5 applies to this example. The perfect interval has been increased by a half step. Therefore, the interval of E flat to B is an augmented fifth interval. Example 2. In the second example, the interval is F up to D. Counting the lines and spaces between the two notes on the staff, we get an interval number of 6. In this example, the upper note is in the scale built from the bottom note. Therefore, this is the diatonic interval of a major sixth. Now you know how to measure intervals. This can be used to derive all the scales and chords you will ever need, because all scales and chords can always be defined by their internal intervals. Finally, I will show you how to read intervals as fast as possible. Unless you're familiar with the major scale built from the bottom note of the interval and the chromatic interval description rules, this is only a fast way to get the interval number. However, I will use the bottom note of C in each interval, and therefore each interval will be diatonic. That is, either major or perfect. Later, we will adjust the intervals using accidentals to turn them into chromatic intervals. That is, either minor, augmented, or diminished. So here are the diatonic intervals in one octave up from middle C. Remember that these intervals will be the same in any major scale. To find the interval number, count the number of lines and spaces between the notes, including the line or space the first note is on. The first interval, which we didn't include in the interval chart, is from the tonic to the tonic. Hence, this is the same notes. This interval is known as a unison. Both notes will be line or space notes. A unison is regarded as a perfect type interval. The second interval is easy to recognize, as there will be a line and a space note in close proximity. The third interval will either be 2 line or 2 space notes in close proximity. The fourth interval will be a line and a space note like the second interval, though this time there will be an extra line and space between the notes. The fifth interval will either be 2 line or 2 space notes like the third interval, though this time there will be an extra line and space between the notes. The sixth interval will be a line and a space note like the fourth interval, though this time there will be an extra line and space between the notes. The seventh interval will either be 2 line or 2 space notes like the fifth interval, though this time there will be an extra line and space between the notes. The octave will be a line and a space note like the sixth interval, though this time there will be an extra line and space between the notes. Let's add another octave below so we have the diatonic intervals in 2 octaves up from middle C. This will introduce us to some new interval names. Notice that the location of the major and perfect intervals is similar to the location of major and perfect intervals from the tonic up to the octave. So the perfect intervals in this new octave are the 2 C notes 1 and 2 octaves above middle C, respectively, the perfect 11th interval, which correspond to the perfect 4th interval, and the perfect 12th interval, which correspond to the perfect 5th interval. All other diatonic intervals are major intervals. Now, let's turn these diatonic intervals into chromatic intervals by adjusting the top or bottom note using accidentals. Using the chromatic interval description rules, we will turn the diatonic intervals into chromatic intervals. That is, minor, augmented, and diminished intervals. The major interval can be turned into a minor, a diminished, and an augmented interval. We'll use the major third interval from middle C to E as our starting point. In these examples, we'll only adjust the top note. We can turn a major interval into a minor interval by making it a half step smaller. We can do this by either raising the bottom note or by lowering the top note. As we'll only adjust the top note in these examples, we will add a flat sign to the note E to make the interval a half step smaller. We can turn a minor interval into a diminished interval by making it a half step smaller. We'll do this by adding a double flat sign to the note E. Going back to the starting point, we can turn a major interval into an augmented interval by making it a half step larger. So let's add a sharp sign to the note E. Next, we'll use the perfect fourth interval from C to F as the starting point. A perfect interval can be turned into either a diminished interval by making it a half step smaller or into an augmented interval by making it a half step larger. Apart from the flat, double flat, and sharp symbols, you can also use the accidentals double sharp and natural to adjust the notes, and thereby turn diatonic intervals into chromatic intervals, or vice versa. Though this requires intervals with accidentals. For example, to turn a diatonic major interval into an augmented interval using the double sharp sign, we need an upper note in the interval that's already sharped. Then, we can use the double sharp sign to make the interval a half step larger, and thereby into an augmented interval. To recap, any diatonic interval is turned into a chromatic interval by increasing or decreasing its size. You adjust the size of intervals using accidentals. So starting with the two types of diatonic intervals, by increasing their interval by a half step, they are both turned into an augmented interval. By decreasing the major interval by a half step, it is turned into a minor interval. By decreasing the minor interval by a half step, it is turned into a diminished interval. And finally, by decreasing the perfect interval by a half step, it is turned into a diminished interval. I hope you liked the video. In the next video, we will look at triads.